Hello, eighth graders. It's Mrs. Johnson this week. We're going to talk about understanding distance and time graphs. And this is page 81 in your math binder. And we are going to do a fun little demonstration. Now, typically, I would make a giant fool of myself and run around in front of the class. But clearly, I can't do that while filming this, or at least I couldn't think of a good way to do that. So I have a little helper here with me today. I'm making it sound way cooler than it is. It is way cooler than it is. So you are going to follow along, and we're going to eventually get to the point where we can explain how Mrs. Johnson would have to move in front of the class to create each of the following graphs: a horizontal line, a V-shaped graph, a vertical line, and an O-shaped graph. You don't know what I'm talking about yet. That is A-okay. So you are going to use the space below to sketch Mrs. Johnson's distance from the door during the classroom demonstration. Use your graphs to answer the questions above. So this whole time, sorry, I said time and pointed to time. The time is going to be passing, and you're going to graph my distance from the door. Now, because I can't actually run in front of you right now, I created a me situation where this is my classroom, the front of my room. The door is over here, and here's my desk. It's very well drawn, I know. And this is going to be me. Look at that cute little guy. I had it in my drawer. So this little guy is me, and I'm starting at the door. And my job is to get to my desk, and you are going to graph my progress. So I want you to watch the first thing that I do. First of all, where do I begin? That's me, remember? And I'm at the door. So on my graph, I am going to begin by drawing my dot with me, Mrs. Johnson. I would use a pencil right now if I were you, at the door. Now, if my distance from the door, if I'm starting at the door, you better draw a dot starting me at the door. Okay, so if I'm at the door and I slowly do this, what was I doing to my distance from the door? I was increasing my distance. And did you see how I went the same speed that whole time? So I am going to draw my distance as a solid, constant moving away, because that's what little old flowerhead me did. I walked away from the door. I walked away from the door. That's kind of hard to see. I'll try to write with a marker next time. But that constant rate was me walking away from the door at a constant speed. All right, are you ready for the next one? Okay, on the next one, I am going to start here, and I am going to do this. Watch what I do. Oh, first of all, if I'm starting that far away from the door, I can't do my dot down here. This time I have to do my dot all the way up here. I'm away from the door. I'm at the desk, which is far from the door. So watch what Miss Johnson does here. Okay. 1, 2, 3. Okay, so you saw me start away from here, and I started going at a constant speed. But then when I got about halfway, I took a break. And I didn't get closer, and I didn't get further from the door. But then I started at a constant speed again, and notice it was the same speed that second time. So on that one, I went toward door, and then I stopped, and then I went toward door, same speed. Because you notice my speed, I didn't speed up there. I went the same speed, so I should see the same rate of change for those two sections. Okay, let's try another one. This one, Miss Johnson is going to start at the door, and I'm going to go okay, so what did I do there? I went away from the door quickly, stopped, away from the door quickly, stopped. I think I did it 3 times. Away from the door quickly, stopped, and then I went slow. Okay, so I started at the door. So I'm going to change colors this time. This one's going to be pink. Start at the door. I go really quickly away from the door, and then I stopped. Away from the door, stopped. Away from the door, stopped. And then I changed my speed and I went really slow away from the door. So away, stop, away, stop, away, stop, and then slow away. You can see that change in the speed. All right, so here's a new one. Starting at the door, and I'm going to change this one to blue in my graph. This one's always hard to demonstrate in front of the class. Watch my speed this time. Okay, I started out really slow and then I sped up. So what does that look like in a graph? Let's try to sketch that. It's going slowly away, but it's speeding up the entire time. So slow, then speeds up. Okay, let's watch another one. I start here. What if I go away from the door, stop, go back toward the door? Here's a really common mistake that I see for this one. People will go away from the door and then they stop and then they draw their line going backwards. The problem with drawing your line backwards is you are telling me that it is possible to go backwards in time. That's not allowed yet, or I don't think so at all because I feel like we'd see people from that. Anyway, okay, let's not get into that discussion. So what would it look like? Well, I would be following the same pattern away from the door, and then I stopped about halfway. But how do I show that I go back toward the door? I can't go back in time, so I have to keep going forward in time, but go back toward the bottom of the graph where you're toward the door again. So this one goes away, it stops in the middle, and then it goes back. Okay, so let's put some words with this. Before we do that, actually, how could we make a horizontal line? A horizontal line would be flat. And what does a horizontal line mean on these graphs? Well, our horizontal lines were always when we stopped. If you stop, it's a horizontal line. How do we make a V-shaped graph? How can I go down and then back up? Well, I'd have to start away from the door. I'd start away from the door. I'd go toward the door. Then I'd spin really quick and go back away from the door. So run toward door. Don't stop, because if you stop, you would get that flat spot in the middle. Run away. How would you get a vertical line? How would you make a line that goes straight up and down? Well, we saw that when you sprinted really fast going away, it got really steep. Is there a fast enough speed where I could make it a vertical line? What does that even mean? What would a vertical line be in this graph? Well, it would mean that at the same exact time, you could be so many distances away from the door. You could be touching the door and touching the desk at the same time. Well, I would have to be a very tall person like Michael Jordan at the end of Space Jam, which I hope you've all seen. If not, there's your homework for tonight. But this is impossible. That'd be being in a ton of places at the same time, which again, not that we know of, that's not possible. So this one, not possible. Time can't stop. Okay, you couldn't see that when I wrote it. How would you make an O on the graph? How could you make, like, would you just have to like spin in a circle like this? No, because that doesn't actually make a circle on the graph. Time's going to keep moving forward. If I'm spinning in a circle like this, that's going away from the door, back toward the door, away from the door, back toward the door. So that would be going up and down because time is always proceeding forward. An O on the graph would mean that you'd have to go back in time. Not possible. Okay, so let's talk about these graphs that are possible. If it is heading upward like that, that means you are moving away. Okay, and if it's flat like that, that is at a constant rate. I'm going to underline the word away. Now, what if it's headed downhill like that? Well, that one would be moving toward. I'm not writing a word. This one, it would be moving toward a door, but in general, you're moving toward whatever it has on your y-axis. So you're moving toward in those. And again, if it's a flat line like that, that is at a constant rate. That means you are not changing your speed. Okay, what does it look like this? Well, that one changes the rate. So you're still moving away, but this one is fast at the beginning and slow. So fast and slows down. This one is moving away again because it's increasing, but it starts off slow then fast. So moving away, slow, then faster. Okay, this one's decreasing the whole thing. So you're going to be moving toward whatever it is. And that is starting out fast then slow. And this next one is also moving toward. And it starts off slow then fast. Okay, so let's apply this to some real problems that are going to be like the ones that you see on tonight's homework. So flip your paper over. We're going to look at page 60 or 82. Use these as reference. And we are going to split this backside up into different sections. So, for example, on Abby's journey home, on the left side, on the y-axis, you've got her distance, and we are going to write in that this is Abby's distance from school. So this is Abby's distance from school. Now we have three main sections here. I'm going to call this first section A. The second section will all be B, and this third section C. And over here, A, B, and C. And you're going to see it like that on your homework as well. So what's happening in section A? Well, if I go back over here, that looks like this moving away. So I would say that Abby is walking, I'm assuming. It says the 4 students leaving school and walking home, label the key features and use your labels to tell the story of the graph. So Abby's walking away from school. So walked away from school. That's all you need to say. How do we know it's walking? Well, it's a slower speed than the next section. The next section gets steeper. So what would you say Abby did right here? Well, she was walking and then she got faster. So what do we call it when people go faster? We use a different word. We are going to say ran away. Make sure you've got both of those words from school. Okay, so she walked away from school, then she ran away from school. What'd she do at C? Stopped. She's not moving further or closer from school. That's how I want you to do these. You are going to do the same thing for Tyler's journey. You're going to have section A, section B, section C. For Hannah's journey, you're going to have section A, section B, section C. And for Antoine's, Anthony, there we go, this is journey. There's just one section that you have to describe and it matches something that we talked about on the front page. So push pause and then you're gonna go over these with me in like 2 minutes, 3 minutes, 5 minutes. I don't know. I'm not sure how long this will take you. Okay, you're back with me. Tyler, we can see that Tyler was walking away from school. It's not very steep. So walked away. How do I know it's away? Oh, by the way, they should say from school for Hannah and from school for Antoine. Okay, so Tyler walked away and then stopped. So walked away from school and then stopped in section D because it's a flat section there. Then, did Tyler's speed change for section C? No. Tyler walked away from school. Simple. Okay, let's talk about Hannah's story. Hannah walked away, but then do you notice how Hannah had to return toward the school again? So Hannah walked away from school, but then Hannah changes direction and starts going toward the school. So we would say walked toward school. Okay, then what did Hannah do? Well, that's a steeper section, part C. You can't just say walked away. That would imply that A and C have the same steepness. C is a lot more steep, so we would say for C, ran away from school. And that's the sort of distinctions I want to see when you're doing your homework. I want to see differences between walking and running. Okay, and for Antoine, we've got, it matches this one where we moved away fast and slowed down. So what Antoine did there is, I'm just going to put a star, headed away from school, slowly, then speeds up. Awesome. Perfect. Wonderful. All right, clip this back in your notes. Use it to help you on tonight's homework. Let your math teacher know if you're having any questions or troubles.